Are gluons really particles flying through the vacuum? Or is there something else happening? In energy filament theory, the conventional textbook explanation for gluons has two fundamental flaws. First, textbooks claim that quarks generate strong forces by exchanging gluons, but they failed to explain the actual mechanism behind the strong forces. Instead, they simply bundle up the phenomena strong, short range, and confined and label them as the strong interactions. This is essentially just naming, not explaining. Second, in high-energy experiments, scientists observe jets or columns of energy, which they attribute to the radiation of gluons. But the logic that if we see a jet, then gluons must be responsible doesn't hold. This is similar to a fallacy in cosmology. If the universe is expanding, distant galaxies' light will redshift, that's fine. But saying since we see redshift, the universe must be expanding is a logical leap. Equating A leads to B within A leads to B. Similarly, in the case of gluons, the claim that jets correspond to gluon radiation, it assumes that the presence of jets directly proves gluons are the cause. According to energy filament theory, quarks are not tiny point-like particles, but instead tiny filaments that are entangled with one another. These filaments form color texture bridges that bind the quarks into a stable, closed triangle. As we've already seen in our previous discussion on electrons, particles need internal circulating flows to maintain stability. Otherwise, they will fall apart with the slightest disturbance. If these texture bridges were completely static, even the smallest tugs would cause the nucleon's protons and neutrons to break apart. This is why the energy C creates fluctuating deformation waves that propagate along these texture bridges, keeping them in a dynamic steady state. The gluons described in quantum chromodynamics (CC) is essentially these deformation waves. They are not individual particles flying through space but rather waves of perturbation on the texture bridges, moving to restore tension and stabilize the system. The fundamental mechanism behind the strong interaction is this locking of textures and patching of gaps, not the idea of gluons carrying force from one particle to another. When particle collisions are intense enough, the extreme tension in the local texture can cause the confined wave packets to be released, propagating along the most efficient energy pathways and moving out of the confined space. From the perspective of an experiment, this looks like energy jets. However, these jets were not caused by free gluons but by high-energy textured wave packets that had been confined within colored tubes. Once they exit the confined space, they quickly decay into a shower of regular hadrons, not gluons flying freely in space. This understanding doesn't deny the success of CD's formulas, but rather highlights the difference in how the strong force is interpreted. The exchange of particles doesn't provide a clear mechanism and mistakenly overradicates the idea of gluons to what are merely jet-like phenomena. In energy filament theory, gluons are seen as high-energy wave packets on texture bridges, with the strong force emerging from the dynamic repair of tension gaps. The jets observed in high-energy collisions are simply the traces of these waves, which emerge from confined channels into open space and rapidly decay. By adopting this view, we can understand the strong force as a result of dynamic changes in the energy C, and not as an abstract particle exchange. The interaction isn't about particles carrying force but about the energy system constantly adjusting to ensure the most stable state. So when you hear about the strong forces in CC, consider this alternative explanation. Gluons are not particles traveling freely, but rather the fluctuating waves that stabilize and guide the forces in the energy C. Next episode preview. Gluons. Are they really particles? Tap follow, share it on New Physics, Clear Universe.